Welcome to a lesson with Dr. Powell. Let's take a look at an application of, linear functions, straight line functions. So let's suppose that we have a lemonade stand and perhaps just the setup for everything that we need to really have the lemonade stand that we want and that we're dreaming of. Suppose it costs $10 for the setup. And then maybe it costs us 20 cents really in supplies and whatever else we need to put out cup. So 20 cents a cup of lemonade. And then, so this is the cost for us. So this is the cost of production. So these are production costs. So production costs. Then maybe we can actually say, okay, maybe we sell them. Maybe we sell each cup for 50 cents. So this is, I'll call this revenue. Revenue is what comes in, okay, is the inflow of money. Of course, we had some outflow too before we got here. Now, if we put the two together, we actually get the profit. The revenue minus the production cost would be then, if we're thinking of total values, then we'd actually get the profit, how much we made. Now let's think about writing each one of these things as a function. Production cost, revenue. Let's just call this a cost function. What does it cost us? Well, first of all, let's think about this. What if we don't sell any lemonade? Let's let X be equal to what we sell, or the number of cups that we sell. Number of cups we sell. And let's suppose that cost function, or maybe for setup or get ready or whatever we want this to be, let's let the cost function be a function of X and depend on X. So let's suppose that X is 0. Then what happens? So if we just set up, well, here's the cost, it's $10. That actually is a point. That's actually an intercept, by the way, because when X is 0, that's like a Y-intercept, 10. So we can think of an MX plus B here and think of just a 10 sitting over here for our intercept, plus 10. Then what about this 20 cents per cup? Well, per cup, think about what that means. Per cup means per one more value of in the X direction. One more cup is one more in the X, which is run. So 20 cents more in an output. Hey, the output of this function is money, right? So it looks like this is rise over run. In other words, it's slope. 20 cents per cup, that's a slope. So we can think, and if we think about in terms of dollars, you'd say 0.2 is our slope. And we have a nice cost function coming from recognizing slope and intercept. Cost is equal to 0.2x plus 10. You can also think we have X cups, that's 0.2 times X is how much money it cost to get those ready. So this is our production cost function based upon getting X cups ready. Now, what about the revenue function? What if we sell X cups? Should be pretty clear. 50 cents a cup. I think this is a per cup. Now, whenever you see per, that's like a division. It's like something over something else. And cup is kind of like the input to our function, or X value. This looks a lot, and this is like, see the units here, cents, and you see a per. If you see that ever, so some unit per some other unit, that automatically you can assume is a slope. So rise over run. So 50 cents per cup. We're looking at 0.5 X, and if we don't sell any cups, we get no revenue. So plus 0 is our intercept. And we can just ignore that. That is our revenue function. 0.5x. Now, how would we get our profit function? Well, we simply just take, but this profit function, realize this x value is has an assumption. It's assuming that we prepared the same amount that we sold. So this x will coincide. So the profit function would then, in that case, with that assumption, be 0.5x minus this 0.2x plus 5. So minus the quantity, and maybe we should write that like this, because we're minusing a quantity, we should use parentheses. So we have proper distribution of the negative, minus quantity 0.2x plus 10. So it looks like our profit function will actually end up being, so you distribute the negative to the 0.2 and 10. So 0.5 minus 0.2 is 0.3. Profit function will end up being 0.3x, and then the negative distributes to the plus 10, so that would be minus 10. So this would be the profit function. Notice that at first, when x is 0, we have a negative profit, so we have to sell so many cups until we actually break even, meaning that our profit is 0, and then beyond that, it keeps increasing. Thanks for watching.